Hey guys, so today we're going to finish up doing U-Substitution, okay? Now, we've done it mostly, up to this point, we've just done it with indefinite integrals, where you're just trying to find the antiderivative pretty much, okay? So now we're going to add in another mix to it where you're going to find the definite integral, right? That's when you have the limits on your integral symbol, okay? So you're trying to find an exact value or an exact number. Need to find exact value of the area. Okay, and what we're going to do is we're going to use U-substitution to help us figure it out, okay? Now remember, when we're doing definite integrals, you have to find the antiderivative first, and then it's always top minus the bottom, okay? So you do the top number first, and then the bottom number second, okay? Now, because these are going to be a little bit different, there's just a couple extra steps that we need to do in order to figure this out, okay? So what I'm going to do, right, I have x times x squared plus 1 to the first, okay? So what I'm going to do is I'm going to treat x squared plus 1 as my u term, okay? So this is now going to be x squared plus 1. So then the derivative of that, okay, is 2x dx. All right. Now I have x dx in my problem, right? So I just need to multiply everything by 1/2, so I get what I have in my original problem. So 1/2 du equals x dx. Okay. Now, here's the next part that we're adding in, okay? Now, right now, your limits on your integral problem are going from 0 to 1, right? And that is because their problem is in terms of, it's just in terms of x, okay? But when I rewrite my problem now, right, I have 1/2 out front, right? And then I have u to the first du, right? Now, I don't want to immediately write my limits back into my problem, because this problem that we have here is in terms of u and not in terms of x. Okay, so what I want to do is I want to change my limits so that they're in terms of u instead of in terms of x. Okay, and it's a pretty easy fix. Okay, so from the first part of the problem, you said that u was x squared plus 1, right? So we're going to use that again. So u equals x squared plus 1. Okay, so the first limit is when x is 0. Okay, so when x is 0, what you're going to do is you're going to plug that back into here, all right? And that'll tell you how much u should be, okay? So u, right, if I do 0 squared plus 1, I get 1, okay? And then the other limit was when x was 1. So when x is 1, u is going to be, so 1 squared is 1 plus 1 is 2. Okay, so when I rewrite my problem now, my limits now are going to go from 1 to 2 instead of 0 to 1. Okay, now you might be thinking, all right, why are we doing this, right? This is like adding more steps back into the problem. But what we did next, right, is we found the antiderivative, right, and then you substituted u back in. Because you've now changed your limits to be in terms of u instead of terms of x, you don't have to plug u back in, okay? You can simply just do the antiderivative with just u to the first. So it's making it a little bit easier for you to plug in, right? There's not these big things that you have to plug into. You can simply just plug it into what your antiderivative is here, okay? So let's finish this. So you got 1/2, all right, antiderivative of u to the first is just u squared over 2, okay? Now, it's a definite integral, so I don't need the plus c. And what I'm going to do is I'm going to go from u equals 1 to u equals 2. Okay, so it's a lot easier to plug in now when we're doing the definite integral. So you have 1/2 here. Now you're going to plug in the top part first, right? So 2 squared, right, would be 4. Okay, minus 1 squared is 1/2. All right, so if you subtract that, you get 3/2. Okay, times 1/2 is 3/4. All right, so the area or this and the solution to this problem is now just going to be 3/4. All right, so when you do the definite integral part, you don't need to plug what u is back in. Okay, you can keep it in terms of u if you've changed your limits. Okay, so you need to do this part first. Okay, so that you can change your problem up a little bit so that you can get the exact answer. Okay, so we're going to move down to number 6 now. Okay, so pretty clear what u should be. So that's x squared plus 1. Okay, which then makes du 2x dx. All right, so very nicely, I already have 2x dx. Okay, so I don't need to rewrite anything. Okay, so now I have u to the third du. All right, now I need to just change what my limits are. Okay, so when x is 0, u, okay, remember you're going to plug it back into what u is equal to. Okay, so when x is 0, u is going to be 1. Okay, and then when x is 2, u is going to be 2 squared is 4 plus 1 is 5. Okay, so my integral now is going to go from 1 to 5. Okay, so antiderivative would be u to the fourth over 4, and we're going to evaluate it from 1 to 5. All right, so you got 5 to the fourth over 4 minus 1 to the fourth over 4. Okay, now 5 to the fourth is 625. So you got 625 over 4 minus 1 over 4, which you guys know is 624 over 4. And then 624 divided by 4 is going to come out to be 156. Okay, so that is your final answer. Okay, so moving on to number 2. All right, so because I have the square root here, okay, it's like I have 0 to 1 of x times 1 minus x squared to the 1/2 dx. Okay, so my u term, 1 minus x squared. All right, so then du is negative 2x dx. Okay, now I already have x dx in my original problem. Okay, so I need to multiply everything by negative 1/2. Okay, so you got negative 1/2 du equals x dx. Okay, so I have my integral, got my negative 1/2 out front, u to the 1/2 du. Okay, so now I just need to change my limits. Okay, so when x is 0, u is going to be 1 minus 0 squared is just 1. And then when x is 1, u is going to be 1 minus 1 squared is 0. Okay, so we're simply just flipping them. Okay, so instead of going from 0 to 1, we're going to go from 1 to 0. Okay, So, all right, so I got negative 1/2 times u to the 3/2 over 3/2, and we're going to evaluate that from 1 to 0. Okay, so we got negative 1/2 times 2/3 u to the 3/2. Okay, so that's going to simplify to be negative 1/3, right? The 2's are going to cancel each other. Okay, now you guys can leave it as an exponent here, or you can rewrite it like with a radical. So you would make this the square root of u to the 3rd, and then that's going to go from 1 to 0. Okay, so you got negative 1/3 square root of 0, right? 0 cubed is 0, minus negative 1/3 square root of 1. Okay, so obviously the square root of 0 becomes 0, and then this just becomes positive 1/3 as your final answer. Okay, so again, we're not substituting the u term back in, because again, you don't need to if you change your limits to be in terms of u instead of in terms of x. Okay, so for this one, I got sine of 2x. Okay, now 2x is on the inside of your sine function. Okay, so that's what I'm going to make my u term. Okay, so 2x, and then my derivative is just going to be 2 du. Okay, now you have one sine of 2x dx. Okay, so to make that, we really need 1 du instead of 2 du. All right, so I'm going to make this 1/2 du equals 1 du. Okay, so now everything is the same. Okay, so when I rewrite my problem, it's going to be 1/2 integral of sine of u du. All right, now we need to change my limits. So u is 2x. So when x is 0, obviously u is going to be 0. And then when x is pi over 4, okay, u is going to be 2 pi over 4 or pi over 2. Okay, so those are my new limits that I'm going to use now. So 0 and then pi over 2. All right. Okay, so this is going to give me 1/2. Antiderivative of sine becomes negative cosine. So this is now negative 1/2 cosine of u. And you're going to go from 0 to pi halves. So negative 1/2 cosine pi over 2 minus negative 1/2 cosine of 0. Okay. So now the 2 points that you're using, right, are here at 0. So that's 1, 0. And then here at pi over 2, it's 0, 1, right? And remember, cosine goes with the x term, okay? So cosine of pi over 2 is the x term at pi over 2. So that's just 0. Minus, now you got negative 1/2 cosine of 0 is the x term at 0, which is just 1. Okay, so your answer just becomes positive 1/2. Okay. All right, and then the last one here. So again, we want to rewrite this so that everything is on the same line with each other. Okay, so you got x times x squared plus 4 to the negative 1/2 dx. All right, so we're going to make u x squared plus 4, which then du is going to be 2x dx. Okay, so we just need to correct it using 1/2. All right, so I got my integral. I'm going to put my 1/2 out front. U to the negative 1/2 du. And then correct your limits. So when x is 0, okay, u is going to be 0 squared plus 4, which is just 4. And then when x is root 5, okay, u is going to be root 5 squared is just 5. 5 plus 4 gives me 9. So I'm going to go from 4 to 9. Okay, so I got 1/2 u to the 1/2 over 1/2. And I'm going to go from 4 to 9. Okay, so I got 1/2 times 2 over 1, u to the 1/2, from 4 to 9. So obviously the 1/2 is going to cancel out the 2. So you just have u to the 1/2 from 4 to 9. Now u to the 1/2, you're just taking the square root, right? So you got the square root of 9 minus the square root of 4. So you got 3 minus 2, or just 1. Okay? All right, so that's how you guys do definite integrals now with U-substitution.